Have you ever wondered if it's possible to live in the sun? Quite an intriguing thought, isn't it? To the uninitiated, it might seem like a question straight from a science fiction novel. But let's not forget, human curiosity knows no bounds, and our fascination with the cosmos is a testament to that. Just think about it. We've always looked up to the heavens, wondered what lies beyond our reach, and yearned to explore the unexplored. The sun, the heart of our solar system, the giver of life, has always held a special place in our speculations and musings. It's a celestial body that's been revered and worshipped throughout history and across cultures. But could we, as a species, ever call it home? To even begin to entertain this idea, it's crucial to understand the role the sun plays in our solar system. It's not just a bright spot in the sky that gives us daylight. It's a massive ball of hot, glowing gases, chiefly hydrogen and helium, held together by its own gravity. The sun's immense gravitational pull keeps all the planets, including Earth, in their respective orbits. It provides us with heat and light, making life as we know it possible. However, the sun is not a serene, peaceful place. Its surface temperature alone is about 10,000 degrees Fahrenheit, hot enough to melt any material that we know of. The core, where nuclear fusion takes place, is even hotter, reaching temperatures of about 27 million degrees Fahrenheit. So the sun, in all its blazing glory, presents a formidable and inhospitable environment. It's not a place we could just pack our bags and move to. But human beings are known for pushing boundaries and defying the odds. We've made it to the moon, sent rovers to Mars, and probes to the outer reaches of our solar system. To understand our chances of living there, we first need to understand what the sun is made of. And that's exactly what we're going to explore in the next chapter. So buckle up, because this is going to be a wild ride into the heart of our solar system. The sun, a massive ball of hot plasma, holds 99.86% of the mass in our solar system. This celestial body is not just a bright spot in our sky, it's a complex and dynamic entity with a composition that's both fascinating and a bit mind-boggling. Primarily, the sun is made up of two basic elements, hydrogen and helium. The lion's share of the sun, about 3/4, is hydrogen. The remaining quarter is mostly helium, with only a smattering of heavier elements like oxygen, carbon, neon, and iron. But how does a ball of hydrogen and helium end up producing the heat and light that sustains life on Earth? The answer lies in an awe-inspiring process called nuclear fusion. At the core of the sun, where the pressure is 340 billion times Earth's air pressure at sea level and the temperature reaches a scorching 15 million degrees Celsius, hydrogen atoms get squeezed together so tightly that they merge to form helium. This process, known as fusion, releases an enormous amount of energy, which we perceive as heat and light. But it's not just about the heat and light. The sun is a powerful celestial body that's constantly in a state of flux. Its magnetic fields twist and tangle, giving rise to phenomena like sunspots and solar flares. The sun's surface, or photosphere, is a seething mass of gas that's about 5,500 degrees Celsius. Above that, the corona, or the sun's outermost layer, is even hotter, with temperatures ranging from 1 to 3 million degrees Celsius. So when we consider the sun's composition, the extreme temperatures, the crushing pressures, and the volatile activity, it's clear that it's not a place for the faint-hearted. In fact, it's not a place for any human heart. With such extreme conditions, human life as we know it could not survive. Imagine stepping into a furnace that's 15 million degrees Celsius. That's the sun for you. Now picture trying to live in such a place. It's an extreme thought experiment, but it allows us to explore the fascinating challenges that such a hostile environment would pose to human life and our current technology. Let's start with the most obvious obstacle: heat. The sun's core, where nuclear fusion occurs, is hotter than anything we've ever experienced on Earth. Even the coolest layer of the sun, its photosphere, has an average temperature of about 5,500 degrees Celsius. That's nearly 1,000 times hotter than the highest temperature ever recorded on Earth. The heat alone would instantly vaporize any known material, including the most heat-resistant substances we've engineered. Next, consider the pressure. The sun's core is under an immense pressure due to the gravity of the overlying layers. This pressure is billions of times greater than what we experience at sea level on Earth. No current technology could withstand such extreme pressures. Let's not forget about radiation. The sun is a maelstrom of nuclear reactions, constantly emitting high-energy particles. These particles would pose a severe health risk to any living creature. they could damage DNA, leading to mutations and ultimately death. Then there's the issue of the sun's lack of a solid surface. The sun is a ball of hot, glowing gases. There's no land to stand on, no water to drink, and no air to breathe. It's not a livable environment by any stretch of the imagination. Finally, the sun's magnetic field is incredibly strong and constantly changing. This could wreak havoc on any electronic equipment, making communication and navigation nearly impossible. So, while our star is a fascinating subject of study, providing us with light and warmth and playing a crucial role in our existence, it's clear that it's not designed for us to inhabit. The sun, while fascinating, is not a hospitable place for humans. While living in the sun remains a fantasy, our exploration of space is not. We are constantly pushing the boundaries of our knowledge and capabilities, and this is nowhere more evident than in our ventures into the cosmos. Current space missions have us reaching further than ever before. Mars, our next-door neighbor, is the prime target, with both NASA's Perseverance rover and China's Tianwen-1 mission exploring its surface. These missions aim to uncover the secrets of Mars's past and whether it once hosted life. But Mars isn't the only object of our curiosity. Jupiter's icy moon Europa and Saturn's moon Enceladus, with their subsurface oceans, are considered potential hotspots for extraterrestrial life. Future missions aim to probe these icy worlds, looking for signs of life in the waters below their frozen surfaces. And let's not forget our own moon. It's set to become a hub for space exploration in the coming years. NASA's Artemis program plans to return humans to the lunar surface for the first time since the Apollo missions. This time, however, we're not just visiting. We plan to stay, using the moon as a stepping stone for future missions to Mars and beyond. Space agencies aren't the only ones looking to the stars. Private companies like SpaceX are making their own strides. SpaceX's Starship, currently under development, aims to make space travel more accessible and sustainable, paving the way for future colonization of Mars. As we continue to explore, we're not just seeking new landscapes, but new life forms. The search for extraterrestrial life is a key driver for many of these missions. Who knows what we might discover as we venture deeper into the cosmos? Yet, even as we reach for the stars, we must not forget our own home. Space exploration gives us a unique perspective on Earth, reminding us of its fragility and the need to protect it. The sun may be out of our reach, but the rest of the universe awaits. So let's keep exploring, keep asking questions, and keep pushing the boundaries of what we believe is possible. After all, the universe is a big place and we've only just started to explore. So can we live in the sun? The answer, at least for now, is a resounding no. We've traversed the contours of this question from different angles, exploring the sun's composition, the trials of solar living, and the future of space exploration. Let's take a moment to recap our journey. The sun, that radiant celestial body around which our world revolves, is not as hospitable as it might seem from our earthly vantage point. It's an enormous, constantly churning furnace of hydrogen and helium, with temperatures soaring to millions of degrees. This fiery ball of plasma is far from the tranquil, solid surface we might imagine. It's a stormy sea of nuclear reactions, emitting intense radiation that would instantly obliterate any object that dares to venture too close. The challenges of solar living are, to put it mildly, astronomical. Our human bodies, as well as the technology we've developed, are ill-suited to endure the sun's extreme conditions. The scorching heat, crushing pressure, and lethal radiation present insurmountable obstacles to our survival. Any attempt to inhabit the sun would result in instant vaporization, which is, needless to say, not conducive to a long and healthy life. Yet, despite these seemingly insurmountable barriers, our spirit of exploration remains undeterred. Our curiosity pushes us to reach out into the cosmos, to probe the mysteries of our universe and seek answers to questions that have puzzled us for centuries. While the sun may be beyond our grasp for now, the future of space exploration holds promise. We continue to develop new technologies, new strategies, and methods that might one day allow us to probe the sun's secrets more closely. While the sun remains a fiery ball of plasma beyond our reach, our curiosity and thirst for knowledge continue to drive us towards the stars. The dream of living in the sun may seem far-fetched, even impossible, but in the realm of science and exploration, impossibility is merely a challenge waiting to be overcome. And who knows what the future holds? So let's keep dreaming, keep questioning, and keep reaching for the stars.